He kōna I purangi tēnei nā te reo irirangi o Aotearoa.
Have you found yourself reaching for a non-alcoholic beer recently? More and more of us are. And as the market grows, more options pop up. Because we also want our non-alcoholic beers to be delicious and varied. But when alcohol fermentation is such a key part of the process, it presents a tricky puzzle for brewers. Kia ora, nau mai haramai ki te ao hurihanga. Hello and welcome to Our Changing World. Ko Claire Kincannon tēnei. In January 2023, backed by the weight of scientific evidence, the World Health Organization stated that no level of alcohol consumption is safe for our health.
A lot more evidence has emerged about the health risks of alcohol, including even drinking at moderate levels. It's now linked to 7 different types of cancer.
Maybe it's this risk of harm sinking in, because it seems that many of us, including, the stats show, younger generations, are shying away from alcohol.
Secondary school kids are saying yeah, nah to alcohol. Those are the findings from Otago University researchers who found striking differences in the way teenage students now socialise.
Earlier this year, the Brewers Guild of New Zealand reported that the volume of low and no alcohol beer we've consumed has increased a whopping 750% since 2019. For craft breweries around New Zealand, this represents a new and exciting market. And it also opens new avenues of research.
These are pretty active, so they're really bubbling.
I'm at the Garage Project Brewery on Arrow Street in Wellington with Dr. Peter Bircham. He's a molecular biologist by training and now the head of research and development at Garage Project, with an adjunct position at Victoria University of Wellington. We're standing in an area of the brewery lined with large stainless steel conical tanks.
You'll have all the beer in there, all the yeast are in there. They're going to be actively fermenting all the sugars, which is producing ethanol but also CO2. And so you have this exhaust pipe coming off the top, essentially going into a bucket, water down the bottom, and it's bubbling through there, and that's what you can hear.
It's really cranking, yeah.
It's quite a lot of production.
Alcohol fermentation is a key step in the process of making beer. The yeast converts sugars to ethanol, and while it does, it changes the flavour of the beer. Not just because of the addition of alcohol, but in other more subtle ways too. This is not a lucky coincidence. Much like the domestication of wolves to dogs, we humans have been training beer yeast over a long period of time. The conical tanks here allow the yeast to settle to the bottom, to be collected and reused.
We obviously go back to commercial yeast every so often, but historically people have just kept going and going and going for really long periods of time. Essentially that's how yeast was domesticated. So beer yeast came from that process of cropping and reusing yeast. So beer yeast is very different from a wild yeast. It's actually one of the most domesticated organisms.
But what if you now didn't want the yeast to produce alcohol? How could you coax it not to, but still get the other flavour changes you'd like? What Peter and the research team he's working with would like to do is develop brand new non-alcoholic yeast strains. First, let's be perfectly clear on what we need the yeast to do. Time for Beer Making 101, which, if you stick to the basics, only needs 4 things: malted grains, or malt, hops, yeast, and water. We start in the yard outside the brew house, which is scattered with stacks of pallets and beer kegs.
So you've got a grain silo over there. That's where all the grain is stored.
Oh, right, so this black corrugated shed behind me.
Exactly, so that's where all the grain is stored.
The grains typically used in beer are mostly barley with some wheat and rye. These are then malted, soaked in water until they start to germinate, and then dried with hot air.
You've got this conveyor system. It just looks like a pipe coming along there, but it's like an auger system that will pull that malt directly into the brew house here.
He's pointing into the brew house, which, well, it looks like a large garage from the front. Black with some colourful wall art and 2 big roller door entrances. And it's filled with a lot of stainless steel vessels, including a collection of large cylinders. They're so tall that you need to climb up a platform to reach the top. These are the mash tuns.
Alright, just be careful, it's quite steep.
So we just climbed up onto the platform and we're right up. We're in the thick of the action here.
Right.
And so in front of me is kind of like it looks like a touchscreen control panel.
Essentially that's exactly what it is. And you can see the different parts of the brew house. You've got hot water, cold water tanks, you've got the mash tun, you've got the kettle, you've got the whirlpool, and then all these valves in between are controlling the pumps that will take liquid from one vessel to the next vessel.
Here they can monitor and control temperatures in the different vessels, which will be different depending on the type of beer they're aiming to brew. To the left of us, a bit of steam escapes from the top of a mash tun, filled with malt and hot water.
It'll be in that sort of 60 degree-ish sort of range where all the enzymes in malt are most active to convert those starches into sugars.
At this temperature, protein scissors in the malt, called enzymes, chop up the starch into smaller pieces, making sugars, mostly the sugar maltose. Once that's done, the spent grain gets separated out as waste and gets picked up by a local farmer. What they're left with is the liquid, which is called the wort.
It'll be transferred over to the kettle. It'll be boiled in there. You'll get a few hop additions. You can see the buckets of hop pellets
Yeah, I can.
down there.
Yeah.
That's called hot side hop addition. So that's the bitter component of beer. Later on in the fermenter, we'll add more hops, and that's called dry hopping. And you don't get that bitter transformation, but you do get a huge amount of aroma. And
Right, so there's so many different places to tweak to
there
get
is,
different
yeah,
flavours
yeah.
out.
So it's essentially 4 ingredients. Fundamentally a very simple process, but there's so many points you can tweak. Temperature makes a big difference, pressure makes a big difference, what kind of yeast you do, what temperature you mash at. They're all relatively small changes, but can have a really big impact on a beer. If you ferment at a really low temperature, relatively speaking, you're going to get a lot more fermentable sugars and a higher alcohol beer. If you go the other way, go to higher temperatures, you're going to get less fermentable sugars and have a lower alcohol beer and have more body in that beer, which is one of the techniques people use in the non-alcoholic beer production is, you want to push it more that direction as well as using the right kind of yeast. But yeah, they're all small tweaks that have relatively big impacts on the final product.
When the kettle is finished, there'll be proteins in the mix that will have clumped and they need to be cleared out along with the hops. So the liquid gets transferred to another, but different, stainless steel cylinder, the whirlpool.
It'll spin around, which is why it's called a whirlpool. It'll make a little cone in the middle of the protein and the hop and the solid material, and then you'll separate the liquid from that into one of the fermentation tanks around us.
Right, of which there are quite a number now that I'm standing on the platform.
There is.
1, 2, 3,
These are all the
4, 5,
smaller
6,
ones.
7, 8,
We'll take you
9.
out back as well, and there's a few more out there.
Okay.
There's maybe 15 or so.
And then it's in these fermentation tanks that the yeast does the job of converting the sugars into ethanol and carbon dioxide. As the fermentation happens, they'll take samples off the mixture to a small lab to the side to test what's called the gravity. Essentially, it's a measurement of how much fermentable sugar is left in the liquid. It's used to determine how much longer fermentation should go and how much alcohol will be in the beer. But also in this little lab, they'll measure the pH, how acidic the beer is.
pH measurements are a big part of brewing. pH is really, really important, so that's controlled a lot. It's also what makes beer safe at the end, I guess, the combination of ethanol plus low pH, relatively low pH. And that's suddenly a big difference with a non-alcoholic where you no longer have that ethanol protection. Right, so pH becomes super important there, but also we pasteurize everything that's non-alcoholic because that safety is such a big concern for us.
Right, because in, say, regular beer, the ethanol, the alcohol, will actually help to kill off some bacteria that might get in there.
And the combination of those two is very effective at keeping it safe. Essentially, making non-alcoholic beer, you're making like growth nutrient for anything that wants to go in there.
Yeah.
So if you're not being careful with that, I think at some point there will be problems. There's definitely been problems where people have had non-alcoholic beers get contaminated. There haven't been any health issues yet, but it's something we're very, very cautious of. And there's not a lot of regulatory framework around exactly what people should be doing. It's something we're hyper aware of and think probably consumers should be very aware of as well. Reach out and ask your favourite brewery what are they doing for safety around non-alcoholics.
Once the beer is fermented, there's resting, filtration, carbonation if needed, and then packaging. But the packing hall is even louder than the rest of the brewery. Garage Project are known for their wide range of beers, says Peter. They often mix things up. And his focus is on those things that are beyond the norm.
I work on, I guess, the more unusual, technically challenging new ideas. So more recent ones, I've worked on a low carbohydrate beer. So trying to figure out exactly what kind of enzymes and what processing should be used to get carbohydrates extremely low. It's slightly different from normal brewing, so that's more what I get involved with.
And these days, a lot of his time is spent on developing their non-alcoholic offerings because of how well they're selling.
It's a huge part of our portfolio. Some years they might release up to 180, 200 different beers in a single year. And then we've got our non-alcoholic range, and the original one is something like 12% of our production for that one beer. And I think all our non-alcs together almost make 20% of our sales and production.
Plus, it's also his research background.
I did a postdoc in Belgium where I switched from, I guess, fundamental biology research using yeast to using yeast to make better beer. And the big focus there was non-alcoholic. So actually over there I developed the non-alcoholic yeast strain that we use here currently. I was kind of surprised. I moved back to New Zealand and Garage Project already had it, and it turned out to be the one that I'd worked on.
So the taste of beer is a complex dance between the 4 ingredients. And the yeast isn't just there to make alcohol.
Malt's going to add grainy, caramel, bready, roasty kind of notes to your beer. Hops, depending on what type they are, might be kind of herbal, like the more traditional ones, or the newer New Zealand ones. And the American ones are very, very fruity, adding that citrus, tropical kind of notes like that. And then yeast will convert some of those flavours, actually remove some of the undesirable flavours from malt. They convert some of the interesting tropical things and hops to different types of tropical aromas, so you get more complexity from that. And they produce a lot of compounds themselves, so things like esters and higher alcohols, which are a huge part of beer and wine flavour, actually.
Now, there are 2 ways to making non-alcoholic beer, says Peter. In one, you make the beer and then you strip out the alcohol. But you need big, expensive machinery to do this, which kind of counts out your small to medium craft brewery. Plus, you can't really get the big flavour that your craft beer drinker wants, which is why they use the yeast method to make non-alcoholic beer, which in New Zealand is anything with less than 0.5% alcohol by volume.
And we're still doing a normal brewing process. There's a few extra steps around pasteurisation at the end, but we're not skipping on anything. And you're not skipping on ingredients as much, if not more, hop goes into it. And the big key difference is that we're now using yeast that can't ferment maltose or higher starches and sugars that are in beer, so they can only ferment the simple sugars. It's a small portion of what's in unfermented beer, and then they'll naturally only produce under 0.5% alcohol.
And the yeast they use is that one that Peter had worked on before in Belgium, which they buy in.
It's a complex one to work with. There's really special conditions required for storing these yeast and working with them. Unlike normal beer, you can't repitch them because there's too high a risk that you'd get a normal beer yeast in there as well, and then you're going to ferment it non-alcoholic and make alcohol. So the yeast cost is actually a lot higher in non-alcoholics because you're using new yeast every time and you're using specialised yeast.
So with this goal of developing a new strain of yeast that will do all the things they wanted to do, and not do, a team has been assembled. This includes Dr. Andrew Mooncatchy of Victoria University of Wellington, who uses yeast to investigate a whole bunch of different things. So, the yeast guy.
Their genetics is so complex, the beer yeast, that you could argue that they're much more sophisticated than a wine yeast.
And Associate Professor Dr. Simon Hinckley of the Ferrier Research Institute, who I think could quite fairly be nicknamed the sugars guy.
Cellulose, we build houses out of it, and only termites and fungi can eat that. And it is exactly the same as starch, except for the orientation of one chemical bond. Yet one has such incredible fine structure it holds up trees and buildings, and the other one we just wolf down with our chips.
They're both beer drinkers, fans of hazies and stouts. So they're committed to help making delicious non-alcoholic beer. To develop a new strain of non-alcoholic yeast, there are 2 ways they want to try. The first is to take an existing commercial alcohol-producing yeast and force it to do something new. It's kind of like reverse domestication, says Andrew, which is why he finds it so interesting.
My PhD was on corn, so I've always been infatuated with domestication and the process and how humans can have such a huge impact on the genetics and the function of an organism, and taking wild corn, which is like 8 tiny hard seeds, to turn it into what modern day corn is. Absolute incredible feat. To take wild yeast, make it, domesticate it, convince it to make great beer, and now we essentially want to almost undo domestication, which is pretty exciting.
The big change that's needed is to do with the carbohydrates and sugar in the beer. Remember, in the mash tun, the starch in the malt is broken down. Starch is a long string of glucose, and it gets chopped into chunks of 2 glucoses stuck together, a sugar called maltose.
By making a malted wort, there's a lot of maltose, 2 glucose molecules together. Now, if the yeast can chop them apart, you'll end up with 2 glucose molecules which can ferment. But if we can stop it doing that, then that'll sit there and it will only be able to use any tiny amount of glucose that's left behind.
This means you have to think carefully about your malt mix and mashing conditions, which set up the sugars you'll have in your final beer.
If you've made a wort by a traditional method and it's full of maltose, you'll have all of the sugar left over, even when you do your fermentation.
It's something Peter and I also discussed, why some non-alcoholic beers seem to taste a bit sweeter. He says the extra maltose helps compensate for the loss of alcohol, in terms of mouthfeel and sweetness. But it does mean there tends to be a higher carb level in non-alcoholic beers. Though, interestingly, even with the extra sugars, they tend to still come out as lower in calories than the alcoholic versions, because alcohol is so calorie dense. But how are they going to convince the yeast to change their tune?
We're going to synthesise a few little molecules which will inhibit that maltase enzyme process. And then if the yeast can still thrive, then maybe that was a particular variant that can get by without doing that process.
Basically, you kind of force evolution to figure it out for you. And that sounds easy, but because of the centuries of domestication, these beer yeast genomes are complicated, especially compared to the lab yeast strain Andrew normally works with.
A beer yeast is typically tetraploid, so 4 copies of every gene and chromosome, much more genetically complex.
There are also duplications of some desirable for brewing genes, like those maltose-snipping maltase ones, and deletions of others, ones that produce unwanted flavours. So they'll need to keep the selective pressure of the maltase inhibitors on these yeast for several generations, and then they'll screen the survivors. So they'll test to make sure that they are maltose negative. That means they can no longer break down maltose to make ethanol. And then they'll check these maltose negative yeast to see if they still have all the nice brewing qualities and haven't picked up any other changes along the way that would mess the flavour up. Genetic modification is another obvious way to try to do this. You could precisely target the genes that encode for the maltase enzyme. And with the New Zealand regulations around gene technology set to change soon, it could be on the cards. But for the moment, the team are only considering it as a comparison for what comes out of their directed evolution experiments.
We have the potential, and that's a common thing in the field, is to use genetic engineering as proof of principle. If the genes are known, then those genes can be manipulated. It's more like almost as a control.
And with GMO, there's the market and public perception to consider, says Peter. But also for this project, evolution might just be better.
If you're doing a GMO approach, which sounds very high-tech and precise, and they are now, but you've got to know exactly what change you want to make. And the real value of natural diversity or a breeding program is that you're not targeting one gene. It could be some really unexpected change that has that winning property you're after. And so you're leaving it to the world of biology to come up with a solution for you, which is going to produce far, far more diverse options than we would do by choosing one gene to target and go tackle that with CRISPR or GMO.
If they can achieve it, then they'll have made a new strain with new IP, with potential for commercialization. Here's Simon.
I think the market for no alcohol is fascinating. Is it boom or bust? Is it just something that's going to be a trend and then go away? But I think the modern generation drinks a lot less than our generation does. So I think it's here to stay, and so I think this is a huge opportunity.
To address those questions of whether it's here to stay, this project also includes Dr. Fanti Chiptono, Associate Professor in the School of Marketing and International Business. He's designed an online survey to collect information about people's knowledge of and attitude towards non-alcoholic beers. Are they aware of them? What do they think of them? Do they drink them? And if so, is that to avoid a next-day hangover or because of longer-term health goals? It's early days in this survey. About 250 people have completed it so far. But they hope it will give them a clue about what's driving the increase in consumption and what consumers are looking for in their non-alcoholic beers. This will help people like Peter understand whether he should be trying to make, say, a non-alcoholic and low-carb beer. But back to the yeast and sugar guys. And to route number 2 for making a new strain of non-alcoholic yeast. Instead of starting with a beer yeast strain and reversing the domestication, well, you could start instead with a wild native New Zealand yeast and see whether it's any good at making interesting beer flavours. Here's Andrew.
They might exist out in nature. They might exist in the wild. Most wild yeast are maltose negative.
This wouldn't be the first New Zealand beer yeast on the market. Our Changing World visited Froth Technologies, based in Wellington, in 2020 to learn about their efforts to investigate the potential of wild New Zealand yeast. And where do you find these wild yeast? Well, everywhere.
Soil, leaves, flowers, nectar, you name it.
So you're going to go and capture a whole bunch of yeast out and about in the environment, grow them up, and then screen them.
Yeah, maybe set up some kind of traps, if you can visualize a yeast trap.
What does a yeast trap look like?
An agar plate. We'll ultimately be able to isolate them, and then grow them up on agar plates in the presence and absence of these inhibitors, and get a better sense of its biochemistry, really.
It's early days for this project, and so far they've used a research fund within Victoria University of Wellington that promotes cross-disciplinary research. But they've also teamed up with others outside of Vic Uni to apply for a larger research grant that would allow them to really get into this. And as part of that, what they're also hoping to do with this project is to explore the question of who should benefit from a product based on a native microbe. If they, or someone else, say even a company that's outside of New Zealand, use native New Zealand microbes and develop them all the way to a commercially viable product, sold for profit around the world, well, who should gain from that?
There's lots of work being done internationally around trying to ensure that Indigenous communities benefit from the genetic resources that are used from their territories.
When I spoke to Associate Professor Maui Hudson, Director of the Te Kotahi Research Institute at the University of Waikato, he highlighted some really interesting case studies around what's called benefit sharing. Like in Brazil, an extremely biodiverse nation, where they introduced laws that mean companies must put 1% of their profits into a national fund for benefit sharing.
If they develop some kind of product from some sort of flora and fauna, that they share benefits from it into a sort of a common pool. And that common pool would then be available for all those different communities to apply to.
It kind of demanded a deeper dive, so keep an eye out for that chat in an upcoming Our Changing World episode. Back in the Garage Project Brewery, Dr. Peter Bircham is eager to find out what the marketing survey discovers. But anecdotally, they're already learning from their customers.
I think there's generally a perception that it's a younger person's Gen Z shift towards not wanting to drink, but from our experience, it doesn't seem to be the case. I mean, they're probably not our target audience in general, but it's really people wanting to moderate their drinking and have a sensible option that is equally high quality to choose. We actually get a lot of feedback. It's amazing how many people just say, we love that these are available now. That we get far more feedback around these kind of things than we do some of the other alcoholic beers. People just really appreciate that they've got serious non-alcoholic options now. We're not obviously not the only ones producing these. I think you're getting a real shift towards higher quality non-alcoholics now. Brewing's got a long history. It's really, well known how to brew, but non-alcoholics is totally new. It's a new frontier. And I think the early editions were kind of faltered. If you've tried non-alcoholics before, you probably realize that they're not quite the same. There is some fault with them because it's a totally new thing for us. It's all exploratory. There's so many lessons to be learned and find our own new way of dealing with these things. So it's a pretty exciting space to work in.
Thanks to Dr. Peter Bircham, Head of Research and Development at Garage Project. Thanks also to Dr. Andrew Mooncachi and Dr. Simon Hinckley of Te Heranawaka, Victoria University of Wellington, and to Associate Professor Maui Hudson. This episode was produced by me, Claire Kincannon. Production help was from Ellen Rikers and sound engineering was by Phil Bench. There'll be photos, more info, and relevant links to this story at our webpage rnz.co.nz/OCW. Tēnā koe I whakarongo mai. Thank you so much for listening. I'm Claire Kincannon. Have a great week. Kia pai, the wiki.